very pleased with your response to our last video, counting method examples. Thank you to everyone who subscribed. This is the last video under counting methods, so I'll try to make a bit of a summary of some of the equations that you need to know. It's not the case that I'll be able to put all the formulas here. Please make sure that you know all the formulas that have been presented to you in your lectures and you understand and know how to apply them. So if we are given n different things, the number of different ways we can arrange them is by n factorial. So if you are given n different letters in a word, you can arrange them by n factorial. If you are given n people to fill n positions, you know that you will arrange them by saying n factorial. So we have the case whereby if from the n things now you only have to arrange r things from that, you know that you will say n permute r. So let's say you have 5 people and you have 4 positions, and arranging those people in the available positions, it will be n permute r. You know that n permute r is the same as saying n choose r times r factorial. Arranging things when some group of items are identical. So in the scenario, they'll even tell you, Hore, this group of things are identical or you can't distinguish between them. So you know that you will use the equation of permutations when some group of items are identical, which is n factorial divided by n1 factorial times n2 factorial until nk factorial, where n is the total number of things that you have and n1 or nk factorial are the number of items you have in each subgroup that is containing identical items. Again, combinations of n different things is 2 to the power of n. So sharing n different things amongst k different recipients, we partition. So you partition based on the conditions that you are given. So in your scenario, you'll determine what is n and k in the different scenarios. And if there are no conditions and you are just required to share the n different things amongst k different recipients, you know that the different way we can share them is by k to the power of n, where k is your different recipients and n are the different things that you must share amongst them. So when sharing n identical things amongst k different recipients, you have to use the sharing formula, which says n plus k minus 1, choose n. Yeah, after the little bit of summary I tried to make there, mind you that if I forgot any of the equations that were presented to you in your slides, just know that they are very important. They are as important as the ones I mentioned. Make sure that you know all of them. So to finish off this video, I'll be doing a quiz that some of you got this year 2020. So guys, it is important to understand your question. So you must read the question, obviously, so that you can know what it is asking of you. And after that, make sure that you know what you are dealing with. Ask yourselves that are the items different or the same, and are we sharing or arranging or doing what? Then from that, read the conditions, and after getting the conditions and getting a sense that you understand what the condition is saying, then work towards meeting the condition and answering the rest of the question, right? So in this video, it's about you seeing the thinking process behind other questions and how you can attempt them. So the first question says the number of different weights you get by rearranging letters of the word Oliver is. So guys, you can see that Oliver is a 6-letter word and all the letters are different. So arranging n different items equals to n factorial. So your answer will be 6 factorial, which is equals to 720. So the last one on the slide says the number of different words you get by rearranging letters of the word permutations. So you can see that permutations is a 12-lettered word. So you can see that we've got 2 T's there. So it means that this is permutation when some group of items are identical. So you know that your answer is going to be 12 factorial divided by 2 factorial. The other one says, suppose the government of South Africa wishes to award tenders for 1. A. Housing construction project, B. 1 IT upgrade project, C. 1 highway construction project, and D. 1 solar panels manufacture project. Right. The number of different companies that are bidding for the projects are 5, 3, 6, and 2 respectively. So in how many different ways may the 4 tenders be awarded? So you can see that different companies have applied for the different tenders that are available, right? So you can see that for the different projects, we won't be choosing from the same companies, because different companies have applied for the different projects depending on what they specialize with. So the answer will be 5 times 3 times 6 times 2. So what we are saying is that of the 5 companies that applied for project A, we are going to choose 1. So you know that 5 choose 1 is 5, right? That of the 3 companies that applied for project B, we will be choosing 1, and of the 6 companies that applied for C, we will be choosing 1, and so on and so on. So the answer will be 5 times 3 times 2 times 6, which is equals to 180. Question says a refrigerator technician is going to repair 10 different refrigerators today. 4 of the refrigerators are making audible high-pitched oscillating noises when running. 3 of the refrigerators have a compressor problem, while the 3 remaining have less serious problems. In how many different ways may the technician repair the refrigerators in such a way that? Number 1 says the first 3 refrigerators to be repaired are making audible high-pitched have the same type of problem. Okay, I'll take that as if the question is saying the first 3 refrigerators to be repaired are making audible high-pitched sounds. Yeah, so we know that we have 10 different refrigerators and they have different problems as stated here. So the A was saying like so the first 3 refrigerators should have audible high-pitched problems. So we know that we have 4 fridges that have that type of problem, and we want to make sure that the first 3 has that problem. So of the 4 fridges that have that problem, we are going to say 4 choose 3, then 3 factorial. So we know that we have a total of 10 refrigerators. Now we've placed the other 3 refrigerators to meet the condition. So the remaining 7 refrigerators, we can just arrange them by saying 7 factorial because there's no other condition to meet. And B says all the refrigerators with less serious problems are repaired first. So the question was saying that all the refrigerators that have less serious problems be repaired first. So we want like those refrigerators to be the first ones to be repaired. We know that we have 3 refrigerators that have less problems, so we know that we are going to start with them and say that 3 factorial. We're going to say 3 factorial, then we will say 7 factorial for the remaining refrigerators, right? So C says refrigerators with the same type of problem are repaired consecutively. Okay, so this is the solution. So here I'm showing you the refrigerators that have audible, high-pitched and oscillating problem, and then the ones that have compressor problems here, and the one that has less serious problems. So they said that refrigerators with the same problem have to be repaired consecutively, right? So you have to repair refrigerators that have the same problem first. After you are done with all of them, you can now start with the other refrigerators that have a different problem. So here we will have 4 factorial for the fridges that have audible, high-pitched and oscillating problems. So we know that we have 4 refrigerators that have audible, high-pitched and whatever problems. So we have that 4 factorial to take care of that. And then for the compressor refrigerators, we have 3 that have that problem. So we have 3 factorial for those refrigerators in here, right, in this circle. And then we have 3 refrigerators that have less serious problems. So we have this 3 factorial for the refrigerators that are in this circle. So now remember, they didn't tell you that refrigerators of the certain problem should come first, then this one, then this one. So we don't know the order and we can't just assume the order. So we will have another 3 factorial. So we have the 3 factorial. It shows that the technician has 3 factorial ways in which he can choose which refrigerators of the same problem can he repair. Like 3 factorial ways in which he can choose the order in which he will repair those refrigerators, right? I hope that you understand. So I don't know how to explain that. So basically, let's say now when the technician gets there, he has three different things to choose from that he can repair. So after choosing the first cycle that he's going to repair, he will have, after repairing that, he will have two to choose from, and then he will have one. So it's the same as 3 times 2 times 1, which is 3 factorial. I hope you get that part. So D says no two refrigerators with compressor problems are repaired consecutively. So this is the solution. I think we've done a lot of questions like this, né? So I really hope you know how to do it. So okay, we know that we have three refrigerators that have the compressor problem. So we know that they didn't say anything about the other refrigerators that have different type of problems. So we will just put them there, 7 factorial. And I told you that every time you have n things that you've placed, the number of positions that are available for the other items is n plus 1. So in this case our n is 7, so we will say that n plus 1 is 8. So we will say we've got 8 positions to choose from, and from the 8 positions choose 3 positions and place the refrigerators that have compressor problems, right? E says the first 2 refrigerators to be repaired have a compressor problem, and the last 2 refrigerators repaired have less serious problems. And we have 3 refrigerators that have compressor problems. So of the 3, we will choose 2 and then say times 2 factorial for the first 2 refrigerators, because they told us that the first 2 refrigerators should have compressor problems. And then for the last part, we will say, because we have 3 refrigerators with less serious problems, so we will say of the 3 choose 2, then we will say 2 factorial. That's for the second condition that said that the last 2 should have less serious problems. And for the remaining refrigerators, now we have 6 remaining refrigerators, we will just say 6 factorial, and your sample space is going to be n1 times n2 times n3. So the second last question says that a librarian has 4 books on surveying techniques, 5 on geological structures, and 2 on algebra. She wants to put all the books on a shelf. The 4 surveying books are indistinguishable, and so are the 5 geological structure books, as well as the 2 algebra books. In how many different ways may she put the 11 books on a shelf in such a way that the surveying techniques books are grouped together on the extreme left? He told us that the 4 surveying techniques books are identical, even the geological structures books are identical, and the algebra books are identical. And then they told you that now these 4 surveying techniques books should be on the extreme left. So they gave us the position that these surveying books should be in, right? So we know that the books are identical. So this one is the same as saying 4 factorial divided by 4 factorial. Remember, when you have groups of identical items, you divide. So it's the same as saying that. So that's why we have 1 here. So because if the books are identical, whichever book you put first, we won't see the difference. They are identical. So even though you change the position of the books, you take the one that was on the 4th position, you put it first, we won't see the difference because the books are the same. So we'll just be like, oh, it's the surveying books. We won't say that they are different, right? So that's why we have 1 there. I hope you understand. And for the other now 7 remaining books, the 5 for the geological structures and the other 2 that are algebra books, we can place them in the way 7 factorial divided by 5 factorial times 2 factorial, and your sample space is going to be n1 times n2. So this is the case whereby now they told us that the books are identical. So please think of a case where all the books are different. Now when they told you that, okay, the books are different, I couldn't find a question that covered that, but I know it's there one way or the other, or some of you maybe did get it. So just try find a question that requires you to arrange maybe different books, right? So this was the last video under counting methods. We'll start a series of videos under probability. So I'll be sure to record those and post them as soon as I can. So if you haven't subscribed, please do subscribe and hit the notification bell so that you get notified when I post. So on that case, the last question says the number of different words you get by rearranging letters of the word subscribe. So we can see that we have identical letters. S and B are identical letters and they occur twice. So the word subscribe is made up of 9 letters. So the different arrangements we can get is 9 factorial divided by 2 factorial for the S and 2 factorial for the B's. So that was all. Please do subscribe and I'll see you when we are doing probability. Bye.